Hi guys, in this video we will talk about return of investment analysis for solar systems. And now when you talk about solar, obviously one of the most important things is how you're going to get your money back and then make money over time. Now there's a lot of misunderstandings and not true knowledge out there in groups and forums and things like that. And that can come from the old technology where the analysis was completely different, or it can just be wrong information that flowing around. And with an analysis like this, you can show and you can know properly how it's going to be over time, which is obviously very important. Now, I've said in many videos that the return of investment on our system, or actually when you get your money back, is about 5 to 6 years. It's shorter on bigger systems. So let's say you have 10 kilowatt, it can be 3 or even 4 years. But it can also be short like that, 4 years, if you have a high kilowatt hour price, obviously. And many customers are in that position where they are paying a surplus because they are not paying to the PA or MEA, they are paying to a community company. So you can check that by seeing if your bill is coming from a community or is coming from the supplier itself. If it's not from the supplier, you are likely paying a premium, and then you should really look at the details of your unit price, and your return on investment for solar will become better. So first of all, when we look at return on investment, we do not look at only the point on when you get your money back. That's only part of it. So in this analysis for a 5 kilowatt system, we can see that the point where you have your money back is here at 5.6 years. This is an assumed price of a system, 200,000 baht, 14 panels. Now I'm talking about our own systems, obviously. 200,000 is quite the standard price now. There can be variation around that, but we'll just use that as an example. And we have calculated 3,000 baht savings per month, which is conservative because now as prices are rising, it seems to become an average where the kilowatt hour price is higher and you will have more than 3,000 baht in potential savings per month. And this also assumes obviously that you are using the energy. If you don't, your savings will be less. So there are a few assumptions, but it's assumptions that you can think of if you satisfy or not, and based on that you can modify your savings. But we have to use a standard setup, and then once you understand how it works, then you can just modify it depending on your needs and your own situation. But the most important is that this kind of analysis highlights the changes over time that occurs. Because obviously as you start saving money and the years goes by, there are things that are going to change. And one of the things is the electrical price, as we see now over the whole world, where prices are going up. So then this number will become higher. But there are some things that will decrease, and I'll just give you an example. The efficiency of the panels will decrease by maybe 0.5% per year. So you have some competing variables there that, for this example, we will just assume that they even out. So we will say that because electrical prices are going up, efficiency is going down, we will just, for this example's sake, to make it easy, we will say that that evens out. Now, obviously, most people think that electrical prices will go up faster than the efficiency will go down. And I agree with that. So if we assume that, we can say that this number will actually increase over time. But anyway, we'll stay on the conservative side because we also don't want to exaggerate the saving possibility. because then we can be accused of falseful marketing. So we don't want to do that either. We want to remain conservative. So I think this is a reasonable but conservative estimation for a 5 kilowatt system where you are using the energy from it and able to do that. So that's why we say 36,000 savings baht obviously per year. So we end up with 5.6 years for get our money back. Everything after that is pure profit. We can see the accumulated numbers here, that after 15 years we have a surplus of 340,000, and we have added 20 years here just to see that obviously as the years go by you will have even more profit and very high profit. Obviously, as the years goes by, the small risk that you have every year that you will have a failure that increases. Well, the percentage doesn't increase, but the cumulative likelihood that you can have a failure, that will increase over the years. So let's give you an example, and that's also obviously related to the quality of the installation. As you start using lower quality equipment, the likelihood that it will fail goes up, and that's why we obviously focus on high quality equipment. So that's why this kind of analysis, it becomes much more fragile on a lower quality installation. That's very important to understand. The lower quality your installation, the higher the likelihood that this will not hold up and you will have failure. And of course you can, if you have a good supplier, they will come and fix it for you. But if you don't, you can end up with enormous problems. And I have so many examples of people I know that have ended up in situations like that, where the company comes and gets the inverter, doesn't return it, suddenly unable to reach them on the phone and things like that, and then they have an unfunctional system for months and months. So those things also have to be taken into consideration, that you need a company that follows up over the years for this analysis to hold through, obviously. And so here we can see the accumulated cash flow over the years. So we're crossing zero here at 5.6. So obviously once we make the investment, we are below zero, and after 5.5 years we're gonna cross the zero line, and we're gonna be making money here over the years. So that's just a way of expressing that. Now, because this is a conservative estimate, and you have many different kinds of system, you have to adjust for these things yourself, how it feels correct for you. And if the price is higher or lower, or a different kind of system, we can also adjust for that here. So let's say that we give out the quote, we can adjust this for that situation. So especially for on-grid situations where without batteries, where these kind of analyses are important, we can put them in every quote to make it visible for the customer. Now, obviously, also warranties are important in this case. That's why I think it's, the 20-year, yes, of course, the lifetime of these components and the system, especially for the panels, is much more than 20 years. Most people, I think in the industry, most experts are talking about 15 years as a reasonable assumption for an inverter lifetime. But that can be plus minus that, obviously, depending also how you treat it, temperature. Also, for example, if you have a bad electrical, that will affect the lifetime of the inverter. So that's an important factor here. So I would say, just example, if you have a three-phase with a nice voltage and very little variation, inverter lifetime is likely to be higher. So you can look at things like that too. But then you are getting into some real details. But some customers like that. They like to analyze and try to understand as many variables as possible, and with this we can actually give that and talk to the customer about how different things change over time. But the main conclusion for most people is that the return of your money is fast now, and it will become faster. So you're looking at, between 3 and 6 years, depending on system size, of to get your money back, and then the profit just increases after that. So it just shows you that solar is a very, very good investment. But it is important to analyze risk also. Of course, there's risk with everything, and if you analyze the risk, then you can also determine maybe where you want to put some more investment in. For example, we obviously have access to all kinds of equipment. We don't have, we are not under contract with anybody. So if you, during your consideration, come to the conclusion that you would like to invest in a specific inverter that's more expensive, then we can look at that and we can do that. So we can have a higher investment, but we can have a little bit better likelihood and better curve here, and less risk of failure and things like that. So this can be used for many things. So that was a few things. So we can get back to this and look at different factors and different size of systems. And so we considered it. This is just an introduction. So any questions, let me know. And also if you want me to focus on certain elements of this, I'm more than welcome to comment. Okay, guys, take it easy.